This is Algebra 2, Unit 6, Lesson 3. And in this lesson, we're going to learn how to complete the square. We're going to learn how to find all of the roots of a polynomial equation or a quadratic equation by completing the square. And this is a tie-in to what we learned in the last lesson of the square root property. We will be using the square root property to solve these, but first we have to force the trinomial to be a perfect square. The first thing you have to understand here is to make something a perfect square trinomial, this number has to be a perfect square. And when you take the square root of that perfect square, if you multiply that root by 2, you will end up with the number that's right here. So in order to force something to be a perfect square, they're going to say what value of c will make the trinomial a perfect square. Now what they're asking you to do here is this is the standard form of a polynomial or a quadratic equation. Now this will either be equal to f of x or y usually. But basically what this means is you've got y equals ax squared plus bx plus c. So when they ask you what c has to be to make it a perfect square, they're asking you what constant belongs there to force it to be a perfect square. So what they will do is they won't give you the 25 at all. They'll ask you to figure out, they'll tell you that that's c. And they'll say, okay, what factors or what number could you put in for c that you end up with a 10 here? Well, in order to work backwards, half of 10 is 5, and 5 squared is 25. That's what the number for c would have to be to make it a perfect square. So in order to find your c value that forces this to be a perfect square, you take the middle term, this is a 4. What's half of 4? Half of 4 is 2. You square 2. 2 squared is 4. So c would have to be 4 in order to make that a perfect square. Now we could check ourselves. If I put a 4 there, x squared minus 4x plus 4. Well, if I do a perfect square, what factors of 4 add to give me 4? Well, that's 2 and 2. Sign tells me they're the same and they're both minus. So x minus 2 times x minus 2. That is a perfect square. So we found the c value that forces it to be a perfect square. How about this one? X squared plus 22x plus c. Find the c value that forces that to be a perfect square. Well, half of 22 is 11. What's 11 squared? 121. So c is equal to 121. 121 would force this to be a perfect square. Now, here's the problem with this. If you have a number in front of the x squared term other than 1, you can't do this method. So we will have to force the number in front of the x squared to be 1 if we want to use completing the square to answer one of these questions. Another problem with this is, what if we have something like this? And they want to know what c is to make this a perfect square, but we don't have an even number here. Well, you can still do it, but it's going to be a little bit more complicated. Half of 7 is 7 over 2. 7 over 2 squared would be 49 over 4. So 49 over 4 would be the number that we would have to put in for c in order to force this to be a perfect square. This is why some people don't like using completing the square, because there's no way around it. Sometimes you're going to have numbers that are pretty complicated that you have to use to complete the square. And that makes your factoring your perfect square trinomial, the binomials that you end up with, that makes those have some fractions in them. And a lot of people don't like to work with fractions. Okay, so this will force you to work with fractions in some cases. Now, the good thing about completing the square is it will work no matter what. Factoring doesn't always work. It will only work if the trinomial I give you is factorable. The square root method only works when you have a perfect square. Completing the square will work no matter what I give you, but sometimes the math involved becomes quite complicated, so you're not going to want to use it very often. Okay, so I would say use completing the square in one of these if you have an even number here, or the directions have told you that you have to use that method. Otherwise, we're going to learn another method later that will work for everything, and it's pretty simple no matter what coefficients or terms you have for your A's, B's, and C's. So your directions for these are going to say solve each polynomial or solve each quadratic equation by completing the square. And one thing you need to understand is that in order to use completing the square, the coefficient of the x squared term has to be 1. If it's anything other than 1, then completing the square won't work. So you have to force your coefficient in front of the x squared term to be 1 if you want this method to work. So we're going to start out with some easier equations to do, and then we'll work our way up to the ones that are a little bit more difficult. For this one, well, in order to solve this using completing the square, I either need the number over here to be equal to 0 or a whole number. It can't be equal to f of x. So if it's presented this way and they tell you to use completing the square, well, all you have to do is write this equal to 0 instead of y or f of x, okay? You need to understand that to solve it, you're finding the x-intercepts, which means y has to be equal to 0. So it's okay to replace the f of x with 0 because you're finding the roots, and that's what you would do when you find the solutions or the roots or the zeros, okay? So with this, the a is a 1. The x squared term does have a coefficient of 1, so that's what we want. But now we have to find the c value here. So we don't want there to be a number here. So if there's a number here already, we want to move it to the other side. So that's what I'm going to do first. X squared plus 8x. Now, I know I'm going to need another number right here, so I'm just going to move the 20 to the other side, right? It was a minus 20, so I move it to the other side. I need to figure out what the c value is that goes here. Well, in order to make the c value, I take half of 8. Half of 8 is 4, and 4 squared is 16. I'm going to add 16. Now remember, in order for this to be a perfect square, wouldn't this have to be a plus? Because if it was a minus, our terms would have two different signs. This is a plus telling me they have to be the exact same. I add 16 here. I'm going to also add 16 here. Next, I'm going to add those together. So I've got 36 on this side. Here, I need to factor. That's a perfect square. So that's x plus 4 squared. Then to solve this, I take the square root of both sides. This is x plus 4 equals, I took the square root, so I have to put a plus minus in front. So that's plus minus 6. Then I'm going to add the 4 over. So I've got x equals negative 4 plus or minus 6. To solve each of those, I have negative 4 plus 6, which is 2, and negative 4 minus 6, which is negative 10. Those are my two answers. Notice this one already has the missing term here. So I've got x squared plus 4x, I'm going to leave a little space, equals 12. To complete the square here, I take half of 4, which is 2. 2 squared is 4. I'm going to add 4 here and on the other side. When I do that, I then can factor. I've got x plus 2 squared equals 16. I'm going to take the square root, and I have x plus 2 equals plus or minus 4. So for my two answers, I have x equals negative 2 plus 4 is 2, and negative 2 minus 4 is negative 6. Now, I want you to notice something here. When we complete the square, notice whatever half of this number is, half of 4 is what's going to go in my two factors. Whatever my half number is what ends up going here. Look over here. Whatever my half number, half of 8 is 4. That's what we ended up having in our factor. You need to know this because when our half number is a fraction, you need to understand that fraction would go here. So it's not as hard to factor using the fractions as you would think, as long as you keep track of what that half number was when you complete the square or when you find your c value. So in this one, I'm going to subtract or add the 18 over. I've got x squared plus 3x. I'm going to leave some space. That equals 18. Then I have to complete the square. This is one where we're going to end up with a fraction because half of 3 is not a nice whole number like we've seen in all the examples so far. 3 divided by 2 is 3 halves. I'm going to put that number over here just so I can remember it so that when I factor, I know what number to put in my factors. So half of 3 is 3 halves. If I square 3 halves, that's 3 halves times 3 halves, which is 9/4. So I'm going to add 9/4 to both sides. Make sure you add that to both sides. If you don't, you're going to have a problem. You're not going to get your answers correct. When I factor this, I've got x plus, the half number was 3 halves, squared. I've completed the square. That equals 18 plus 9/4, which is 81/4. Now, use a calculator to do that. You're not going to have to do that in your head. Use a calculator, use Desmos to find that number. Now, just like before, that's perfect square. It might not be a perfect square. It doesn't matter if it is. We can still take the square root, whether it's a perfect square or not. We take the square root of both sides. This side is going to be x plus 3 halves. This side will be plus or minus the square root of 81/4. That's the square root of 81 over the square root of 4, which is 9 halves. So I have x equals negative 3 halves plus or minus 9 halves. Now, be careful. Don't leave it like this. You need to solve and get your two separate answers. Negative 3 halves plus 9 halves is 6 halves or 3. Negative 3 halves minus 9 halves is negative 12 halves or negative 6. So you get nice whole numbers for that one, even though your work was a little bit messy. For this one, remember, the only way we can complete the square is if the coefficient of the x squared term is 1. So we have to divide everything by 2 so that we can force this to have an x squared term of a 1 in front. So we're going to divide every single thing in this equation by 2. So I'm going to divide the left-hand side by 2 and the right-hand side by 2. If I do that, I have x squared minus 5 halves x plus 3 halves equals 0. Next, I need to move the 3 halves to the other side. And then I need to divide 5 halves by 2. Well, if I divide that by 2, I can do that on my calculator. 5 halves divided by 2 is actually going to be 5/4. So when I divide that by 2, my half number is 5/4. I like to write it here so that I know what to put in my binomials when I'm factoring. And then I have to square that number to know what to add right here. Well, 5/4 squared is 25/16. So you see how some of these numbers start getting very difficult. If I add 25/16 here, I have to add the same thing to both sides. If I forget that, that's going to make my answers very wrong. So you have to be very careful. Make sure you do that on both sides. Anything on the left has to be done on the right. Anything done on the right has to be done on the left. All right, so if I factor this, I have x minus, we know it's going to be a minus, and then the half number was 5/4. That's squared equals negative 3 halves plus 25/16 is 1/16. So now I did that on my calculator. You don't have to know how to do that in your head. It's okay, just use a calculator. The next thing I have to do is take the square root of both sides. I've got x minus 5/4 equals plus or minus the square root of 1/16 is 1/4. So then I have x equals 5/4 plus 1/4 and x equals 5/4 minus 1/4. My two answers will be x equals 6/4 or 3 halves and x equals 4/4 or 1. Here I have 3 more problems. I want you to try these on your own. Pause the video and see how you do, and then we'll come back and solve them in a minute. For this one, I moved the 11 to the other side. Half of 4 is 2. 2 squared is 4, so I added 4 to both sides. That ends up giving me a negative 7. I factored that as x plus 2 squared. When I take the square root, this ends up being an imaginary number, plus or minus I square root of 7. Then I add the 2 or negative 2 to both sides. So negative 2 plus or minus I square root of 7. In this one, I moved the 3 to the other side. Then I completed the square. Half of 2 is 1. 1 squared is 1. So I add 1 to both sides. That gives me a negative 2. When I factor, I get x plus 1 squared. Take the square root of both sides. I end up with x plus 1 equals plus or minus I square root of 2. And then I add the negative 1 to both sides. So that again is complex. X equals negative 1 plus or minus I square root of 2. In the next one, I'm going to divide everything by 3 because the coefficient has to be 1. So I have x squared minus 2/3 x minus 1/3. I move the 1/3 to the other side. Then I take half of 2/3. Now, the good news here is anytime you have an even number up here, half of that fraction is just going to be half of the top number over the denominator. So half of 2 is 1, so half of that would be 1/3. So that's my half number, 1/3, so that's what ends up being here. 1/3 squared is 1/9. I add that 1/9 to both sides. 1/3 plus 1/9 is 4/9. Again, you can do this on the calculator. Then when I factor this, I end up with x minus 1/3 squared. I take the square root of both sides. The square root of this side will be x minus 1/3. This side will be plus minus 2/3. Then I add the 1/3 over to both sides. So 1/3 plus 2/3 is 1. 1/3 minus 2/3 is negative 1/3.